Hello there, my name is Preslav Mihaylov. I am the head of training at Software University and I'm also a software engineer here. Today we are talking about regular expressions, or more the shorter name regex, which helps us achieve advanced text manipulation. We'll first cover what regex is, why we use it, why we need it, and how we use it. Then we'll cover the different components of regex, like characters, operators, constructs, and many more. Afterwards, we'll see what regular expressions in C# are, how do we use them in C#, because regex actually can be used in many different languages, and C# is only one of them, which offers an API for using them, and we'll explore just that. So now let us start, and I can't wait to start when I feel that you are with me on that. So, if you're ready for some new knowledge, now let's go ahead. Now let us see what regular expressions actually are. Well, a regular expression looks like this. The thing at the top. It's a bit funky, but it's basically a specification for how you want to get some data from a text. For example, I'll let you understand this better with an example. Imagine that you have a string, a set of strings which can be anything, but you also have emails in them. For example, you can have hello. You can have the string Ivan at abv.bg, which is a Bulgarian mail service. You can have George. You can have me at Mihaylov.com. You can have SoftUni. All of these are examples of strings, but only some of them are emails. And how do we find an email? Well, the thing is, we have a problem here. We have a set of strings and we have to identify which of these strings are actually emails. So, which strings are emails? Well, these are the strings. Emails might be those strings which contain the @ symbol. For example, in this case we have several matches. We have Ivan at abv.bg, which is an email, and that's correct. We have me at bmihaylov.com, which is also an email. So those two are actually correct email addresses based on the specification we have. The rest are not. However, if they pass a string which is at, A or Obama, is this an email? According to our specification, it is, but actually it's not. So there should be some other, rules we should enforce as well. And how do you achieve this? Well, the easiest thing you can do is you just do some for cycle with a string and check whether it contains an @. But what if you have some more complex conditions? For example, you want to have an email which starts with a letter. You don't allow emails which start with no letters. Well, then you can modify that for cycle and do something else. But maybe you want to have you might have a specification which says that you want to have some alphanumeric string, let's say some words dot some words here, and that's an email. Okay, so you can have different specifications about what kind of pattern you're trying to match in a string, and the way you can achieve that is by using normal string operations. But doing all different string operations for things like that can be really exhausting. It can take a lot of time, and sometimes the conditions you have can be really hard. That's why you have regex. What regex gives us is something like a language for finding patterns, for defining patterns, let's say. Defining patterns. For example, with regex you can easily say I want to have a string which contains the @ symbol. You can say I want a string which starts with number, or a string which starts with a letter. And the thing is, you can do that with normal knowledge you have so far, but with regex it's much easier, because with regex you have something like an API you use and apply. However, it's not exactly an API, because you're not invoking some specific method which says get all strings which contain the @ symbol. However, you have this specification of a language which defines patterns, and that's what regex is. It's a language which defines patterns, and then you can use those that specification to check if the pattern you define matches. For example, here, look at this. This is an example. Well, come on. This is an example of a pattern. It looks very cryptic. It's not a real string. It doesn't bring that much value in terms of the words in it or anything. But this actually defines a specification for some pattern. In this case, what it actually does is it says, I want to match an uppercase, a string starting with an uppercase character and having letters afterwards. For example, a string like that can be Preslav, like this. This is something which matches this. This is the same thing. This says I want to match the same thing. For example, Mihaylov. This is another thing which matches. Then I want a space and a dash, and then I want to match an email. This matches an email. It says I want to match something which has a word, an @ symbol, a word, a dot, and a word again. And having this specification here allows us to match some patterns. For example, Ivan, Ivanov, with some email. And here you can even see how the color coding helps us realize what part of the regex catches which part of the matches. For example, this thing corresponds to this. This thing corresponds to this. This corresponds to that, and etc. etc. So as you can see, with a regex you can define what patterns you want to match, and then against that pattern you've defined you can see whether the string you're given matches or not. That way you can filter all strings from a list which are emails. You can filter all strings from a list which are sites, and things like that, depending on the use case you have. So for now, maybe these special letters here you wouldn't be able to understand them, but maybe based on this example you get some hints what those strange things in the pattern might mean. And now it's time to explore that. Now, since we know what regular expressions are used for matching some patterns, we can start exploring how we build them and how we use them. Before that, I want you to make a research and read more about regex. Read an article about regular expressions. Understand why we use them, where do we use them. Give me some use cases, or think of some use cases where this tool can be useful. Okay? And after that, go to the next video where I'll be waiting for you, where we'll start actually exploring how a regex is being built. We'll start by covering what a character class is. From now on, we're starting to cover the different utilities that a regular expression gives us. One of those utilities is defining a character class. Before that, let me give you an example of the easiest regex you can think of. Imagine that you want to match every string which is just Preslav. Or okay, I don't want to be Preslav, let's say programming. you want to match any string which is like that. Well, you can make a regular expression in which you pass directly the letters programming, and you will be able to match them. And now I will show you a site where you can practice that. The site is called regexr.com. This is a site where you can test regex in a very simple way. What you do here is you write your pattern. This is where you write your regular expression. That's where you define what you want to match. And here you have some text which you can use for testing. The simplest regex you can write is plain text. For example, if I write below here, you will find all the occurrences of below in the text. In this case, it's 1. If I write regexr, you will find all occurrences of regexr, and this is case sensitive. The case matters here. You can find everything which is a comma, and here you can see there are 4 commas. You have one here, here, and here. So the easiest way to create a regex is just writing plain text, and then the pattern you're searching for is the exact characters you provide. This is an easy way for searching, let's say, for a substring in a string. By using regex, you can say, I want to find all the occurrences of Linux in my text, or I want to find all the occurrences of text in the text I'm given. In this case, it's 1. Okay, so that's the easiest type of regex. Now we'll cover the more advanced parts of it. These are, so far, what I just covered shouldn't be something strange. It shouldn't be something that new, because it's really simple. You just write some text and you're trying to find it in a bigger text. It's like trying to find a substring in a string, but this time we're doing it not with for loops and some algorithms, but we just use regex. And one remark I want to do here, what I want to say, here in this site you can test. You can write regex and it will show you patterns. So far we don't know how to apply these patterns into programming, but understand that by the end of this lecture you will see what Regex API you have in C#, and once you understand it, all you gotta do is apply what you learn in this site, and it will directly be applicable inside your C# program as well. So don't worry about that. We won't see that much code in this lecture, but we'll see by its end how we use this knowledge, how we use regex. For now, understand that we will use regex in this site in order to match some patterns, while later we'll see how we can use these patterns to find something in text in C#. So now let's start with the different parts of regex. First is a character class. So imagine that you have some text, and well, okay, I'll give you an example here. Imagine that you have, let's say, the string, I don't know. Well, I'll just use the string kate. Okay, let's just use soft uni. So what you want to do now is find all the strings which contain oft uni and as one of the letters, let's say S, P, N, or something like that. For example, you want to match all the cases of soft uni, poft uni, noft uni, whatever that means. So you want to match all these cases. You can want to find either of these classes. So what you're trying to specify here is match either, well, S, P, or N, and match exactly oft uni. So that's what we're trying to say. Match either one of these characters and then match the string oft uni afterwards. So how do we do that? Well, the thing we use is a character class. It looks like this. You use square brackets and you specify characters. What this means is you want to match either of these characters. For example, this means I want to match either N, V, or G. Let's see how this is applied. I have, well, I'll just see it right here. Soft uni, poft uni, noft uni. So you want to match soft uni and you write this, but this doesn't match the other two strings. What you can do then is use a character class and say, look, I want to match any one of these letters. In this case it's 1, but you can continue and write P and N. And once you do this, I'm saying I want to match oft uni and any of these characters. So this is something which matches. Well, these three are the ones which matches. And once we hover over it, you can see here the explanation. It says I'm matching first a character set. It can be any one of these characters, S, P, or N. Then I'm matching the characters O, F, T, U, N, I. Exactly. So that's what your regex is trying to say, and this is what you match. Okay? So that's a character class. You can specify match either of these characters. And you have some other derivatives of the same principle. When you add the whatever this symbol is called, I'm not sure how you call it, whenever you add this to the start, it means I want to match anything which doesn't include these symbols. What if you don't want to match soft uni, poft uni, and noft uni, but you want to match everything else, like A oft uni, Q oft uni, and Z oft uni? In this case, what you can do is make that well, whatever operator that was. It means I want to match any character which is not in this range. So it's something like negation. It's like you say, I don't want to match either S, P, or N. I want to match anything else, but not those. So in this case, soft uni, poft uni, and noft uni aren't matched because they contain that characters we're trying to avoid, but everything else is matched. So far we learned the basic structure, SPN of a character class, match any of the characters, and this one with the I have to learn how to call that. Well, let's call it an upper arrow. With the upper arrow, you say match any other character. So that's it. That's what the character class does. And another derivation, another kind of character class is one in which you specify a range. Imagine that you're trying to say, look, I want to match any letter. So one way to match any letter is to write A, B, C, D, E, F, G, H, I, J, K, and on and on and on till you get to Z. But instead, since that's tedious, you can specify a range of letters, and you can say I want to match anything which is in the range from A to Z. And once you do that, you match all the strings here because they all start with a capital English letter, which is this pattern here. So if you see the explanation here, notice that this is a range. So we can use character classes not only with distinct characters, but we can also specify ranges of characters, like in this example. Notice that this won't match, let's say, soft union with lowercase. If you want to include the lowercase letters as well, what you can do is you can just add another range. But this time the range is for the smaller letters, from A to Z. Wait, why is this not highlighted? I got confused here. Oh wait, this should be uppercase. Sorry. Kyoftuni and Zoftuni. So notice how previously we had a problem that the U should have been capital case because we're trying to match it with capital case. Previously it wasn't. Okay, so here we try to match any English letter, whether it's uppercase or lowercase, and that's one way of doing it, by specifying ranges. What if you want to match digits? Let's say 0 of the uni, 1 of the uni, and things like that. Then you can specify number ranges like 0 to 9. Well, I should add the O here. And you can also not only use the whole range, you can use part of it. You can, for example, say I want all the digits to match which are between 5 and 9, like here. And now 0 and 1 of the unit doesn't match, but if I write 5 of the unit, it matches. So that's it for a character class. And now I have a challenge for you. I want you to write a regex which matches soft uni but keeps all the other matches as well. Notice the reason we don't match soft uni now is because we're expecting an uppercase U here while they're providing us a lowercase u. So I want you to write a regex which will match both this and this. Well, not this, but these. Okay? So that's your challenge. Now open regexr.com and attempt to do it. So that's it for character classes. Basically, you can match specific letters as you want, not only letters, but any kind of symbol. You can match any other symbol, but not those which are specified. And you can match ranges of digits. Okay? You also have some other ways of specifying character classes. This is, well, a bit more simplified version. For example, if you want to match a word, you can use /w, and it matches any word, which means write A to Z uppercase, or these. In other words, if I now write the quick brown fox went over the lazy dog. If I have that, and I remove this regex now, I write, I want to match all the letters. So I can write, well, I want to have all the letters which are lowercase, but let's say they're uppercase letters. Well, then I'll just add the uppercase letters range. But what if there were numbers? What if this was O? And this as well. What if this was 1? So you want to match digits as well. Then you add another range. And this goes on as well. Finally, you can have underscores between those words, like this. What do you do then? Well, you add the underscore character. And this complex character class matches any lowercase letter, any uppercase letter, any digit, or any underscore character. And there's a simplification for it. And by the way, this only matches a single character. In order to match a whole word, you have to add the plus sign. We'll explain this plus later, but for now, understand that if I write it just like that without the plus, it match individual characters. I'm saying I want to match any character of this range, but I want to match only one character, which means that I'll match T, H, E, underscore, Q, U, 1, on and on and on until the end individually. If I want to match them as a whole, you can add the plus character, which tells me I want to match any digit of this, but I want to repeat it until the pattern no longer matches. Okay? In this case, we're saying, look, until here, every single character matches this character class. But once we got to the white space no longer matches that, so that's where we finish. Okay? So that's what the plus does. for simplicity. Of course, it's a bit more complicated, more involved, but we'll see it later. And a more simpler way of doing the same thing is you can just write /w. /w plus means, well, /w means match. Well, this is the same thing as writing a to z 0 to 9 underscore. It's just a simplification. And if you want to achieve the word thing, you can write the plus. So this matches any character in the range from lowercase letters, uppercase letters, digits, and the underscore. As in this example, it matches this thing. It doesn't match these because these are either not English characters or special characters. If you have the same thing but uppercase, it means match anything else. It's a negation. So it means match everything which doesn't match that pattern. Notice how here we matched ABCD 09 underscore, but here we matched everything else. So when you write something like that, not only for the W, but for any kind of character class of this type, when you write it with an uppercase, it means I want to match everything which doesn't match that pattern. While if you write only one W, it means I want to match it. Okay, so it's like a negation. There's others as well. The S means match any white space character. For example, if I write /s, it will match all the white spaces. Here we have 4. If I go down, you see all the white spaces matched. If I write S, uppercase S, it will match everything other than a white space. In this case, it's this thing here. So this is everything other than a white space. Okay? Similar to how the W works. And D matches any digit. The D here says I want to match a digit. For example, if I write 0 to 9, I'll match all the digits. But if I write /D, I'll match the digit as well, which gives me the same result. And if I write uppercase D, it will match everything else. So these character classes are simplifications which you can achieve by only using this, by using the normal character class where you specify some range or specific characters. Since there are some ranges, some character classes which are very often searched for, like any letter in the English alphabet or a digit, you have special character classes for them which are easily accessible with a specific character like a W, an S, or a D. But notice that this is only a simplification. Even if you don't know this part of the character classes, you can still achieve anything you want using just these 3 bits. So that's it for character classes. Now go to Regex R and practice a bit with it. I'll give you a challenge again. I want you to match the following text. Programming is the #1 thing! Exclamation mark. So I want you to match every single character of these by using the character classes we just covered. So that's your challenge. I'll see you in the next video. Another concept, another thing which we can use in Regex is called quantifiers. What a quantifier is something we already saw actually, one example of the plus sign, but essentially what it helps us do is we can say take a pattern and repeat it for some time. For example, you want to match some specific pattern more than once. For example, previously I showed you how you can match words or for now letters. You can write /W and you can match everything, but you match them individually, independently. If you want to say I want to match this pattern continuously, you use the plus sign. What the plus means is I don't want to match a single letter, I want to match it multiple times. More specifically, the plus sign means I want to match this, the previous element, once or more. In other words, this will return true. I mean, it will match something when there is at least one occurrence of the /w. For example, here, this programming thing is matched because it has the p, this matches the first time, and it continues matching on and on and on. There is no limit. You can match very big words. This is essentially a pattern for matching words. It says, take any word character, which is a letter or a number or an underscore, and match it more than once or more times. So that's what this plus means. There are others as well. The star means I want to match the element 0 or more times. So it's very similar to the plus, however, it gives you the possibility to match the element 0 or more times. For example, if I write the star here, it will match, well, what would be the difference? In this case, there is no difference, but I'll give you an example where this can be useful. So, removing the pattern. Let's say you have SoftUni is a great place. You want to match this exactly. So you write SoftUni is a great place. Now, in order to match these characters, I have to escape them, and then I match this string exactly as is. If I change anything in it, it changes totally. But what if I want to have this thing as a placeholder? That is, I want to have everything else as is, but this thing in the square brackets, I want to be dynamic. I want to be anything. For example, I want to match this, but I also want to match SoftUni is a bad place, or I want to match SoftUni is a awesome place, although that doesn't make sense grammatically. But anyways, I want to match all three patterns here. What you can do is you can write /w plus. When you write /w plus, it means match any letter more than once. So as long as you have valid letters here, you will match them. For example, if I write SoftUni is a something place, it will still match because you have a letter repeated more than once. Okay? But what if it's empty? What if you want to match SoftUni is an empty place? Well, you don't have anything. And I want to include both these things on the top and this thing on the bottom. Now, in its current form, we're not matching anything because the plus quantifier means I want to match a letter at least once for this pattern to be valid. In this case, there is no letter, so there isn't even once a letter here between the brackets. But if I use a star instead, it means, look, I want to either match this infinitely many times. I want to match a letter infinitely many times, or I also assume it can be empty. I would also match it being empty. Okay? So that's the difference between a star and a plus quantifier. The plus matches, gives true, returns true, matches the pattern as long as whatever you specify matches at least once. It can match multiple times as well, but it has to match at least once, while the star will also match the infinitely many occurrences of, let's say, a letter, but it will also match an empty string, like in this scenario. That's what the star and the plus quantifier do. And what the question mark matches the element 0 or once. So that's when you want to have something either there or not. For example, let's say, well, I fucked up this. Let's say I'm giving you my email. Maybe I won't give it, but let's say preslav@gmail.com, and I want to match it. Well, I write @gmail.com, and I want to have Preslav beforehand. By the way, this should be escape. So now we match this email. However, in Gmail there is this option that you can have infinitely many dots between the names. For example, in any Gmail name, which is pr.aeslav@gmail.com, this email is the same as the above one. p.reslav@gmail.com is the same as well. pre.slav@gmail.com should match as well. So all these should match along with the first one. So what you can do here is apply the question mark quantifier. What I'm trying to match is a dot. You're trying to find a dot here, a dot here, a dot here, 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 or here. I'm not sure whether you are allowed to do it in the end. Well, let's just start for simplicity with this one. Okay, now we match this case, but now we don't match the last case, the first one, which was ultimately the most basic one. So how do we match it? Well, what we can do, what we actually need is to match this pattern, but allow the possibility for there to be a dot on the second place. In this scenario, you can apply the question mark. When you apply the question mark quantifier, it means I want this symbol 0 or 1 time. In other words, if that dot there is not present, that's fine. I will still accept the pattern. If it's present, I will accept it as well. So it means it can either be there or not. Okay? And in order for this to be legit, I have to do this pattern for every single space, like this. Now we'll match any possible variation of this pattern. As you can see, all we did was we had the PRESLAV matching, but we have these question mark quantifiers with a dot as well. Okay? So that's what the question mark does. It tells us match the previous thing either 0 times or once. And it can be useful when something can either be there or it can be invalid. One more example is, let's say you want to match a valid variable name. A valid variable name is one, let's say in C#, which starts with well, characters. Let's say num is valid, but 9num is not valid because you can't start a variable name with a number. However, you can start a variable name with an underscore. This is also valid. So a variable name is one which either starts with an underscore or has normal letters. Now, of course, you can always have the variable name this, which is valid, but I won't suggest doing it, and we won't cover that case. Okay, so we want to match num and underscore num. The first one we can match by writing num directly, or just writing match any letter. So A from Z, A to Z, and that's it. And you want to match it multiple times. But notice how in the second case we don't match the underscore character. So we can write, hey, I want to match the underscore character as well in the start. But then we don't match the first pattern. That's why we can use the question mark to say I can either have an underscore character or not. And then I want to have letters. That way you match a variable name which consists only of letters, but you also match a variable name which starts with an underscore. Now, of course, variable names are not validated by this kind of regex. I mean, this won't match all the valid variable names. For example, if I write num9, this 9 here won't be matched, so I'll have to extend this regex to cover it. But that's not important. I just want to make this as a remark, not to be confused. What is important here is to understand how the question mark works. It says match the previous thing either once or 0 times. So that's about the quantifiers. To recap, the star quantifier, the asterisk quantifier, tells us to match something either 0 or more times. That is, it can be there or it can be there more than once, many times. The plus sign, the plus quantifier, means I want to match the previous element 1 or more times. It means that if you have an empty string there, that won't be valid. But if you have at least one character which matches, that is valid. And finally, the question mark tells us you can either have it 0 times or once. That is, whatever this is, it can match only 1 time or only 0 times. So it's something like a special case in which you have the normal pattern, but there is one character which can go in there, which is a special case. In that case, you can use the question mark. Let's see. With the star, you match plus 359 something something and the plus as well. Why is that? Well, the plus is always matched in the 3 cases. Then we're saying match a digit. Well, here's a digit here. Here there's no digit. With the asterisk quantifier, we're saying I want to match the digit either 0 times or more. In this case, this is the more case because we have many digits and we're matching them. But we also match this because although you only have the plus sign and no digits afterwards, we said that it can be there 0 or more times. So in this case, it's 0 times. There are 0 digits, which is still correct. With the plus sign, however, the second case won't match because the plus quantifier means I want to match the digit 1 or more times. In this case, the upper scenario matches because you have a digit and you have it at least once. You even have it more than that. But in the second scenario, this is not matched because, well, you don't have any digit. It should be there should be at least one digit there in order for this pattern to be valid. And with the question mark, it means I want to match a digit only once or 0 times. In this case, we match this 0 times because there is no digit. It's okay to not have a digit, it's optional. But in the above scenario, we will only match the first 2 symbols of the string because this doesn't say match 0 or more times, it says match either 0 or exactly 1 time. So in this case, it matched exactly 1 time and it didn't match the rest of the pattern. So with these 3 visual examples, you can understand what's the difference between the different quantifiers. So now, let's think of a challenge. I showed you that this is not a valid regex for matching variable names. Your challenge is to write a regex which can correctly match variable names in C#. Let me remind you, variable names begin with an underscore or a letter, contain letters, digits, and underscores. So, in other words, the character num is correct because it starts with a letter and contains letters, digits, and underscore. NU9 is correct. Underscore num is correct. Num underscore is correct, but 9 num is not correct. So I want you to write a regex which will match these cases, but not this. Okay, that's your challenge. Go on, have fun, and I'll see you in the next video. A short video about character escapes, which we have to mention in regex. Sometimes you need to look for some special characters. and these special characters might be a tab, for example this, or a new line. The way you can match this is by using escape character, just like in normal programming when you, well, not the W, this thing, and this thing. And the way you do it is just like you would write it in a C# program, with the escaping character and the special character which denotes whatever you mean. In this case we have a tab and a new line. Let's see this in practice. I have, let's say, name, I click tab, Preslav. Then I have a new line, last name, tab, Mihaylov. So I want to match both these things, not only one of them, but both. And I can start writing. I want to have name, then I have to want a column, then I want a tab. Now if I write a space here, if I click 4 spaces or a space, it doesn't match this tab character. In order to match a tab character, you have to write \t. \t means I want to match a tab character, which means the character 2 keys underneath your escape key. It's the thing with which you open your score in Counter-Strike if you're into that stuff. Then I want a name. Now I would match a name with a W plus. And now I just matched this part. But now I want to go to the next line and match last name with something else. In order to do that, I have to match a new line. Well, how do I match a new line? I can't just write enter like this. I'm trying to click enter, nothing happens. In order to say I want to match a new line, you have to escape it and write /n like this. And finally you write I want to have the last name, colon, tab, and a word again. Notice what we matched. We matched this whole thing because we matched name here, a tab character, some word, and then a new line. And starting again, last name, tab character, and some word, and that's it. So there are some cases like this in which you would like to match these special symbols. Some of these special symbols are tab and new line, and this is the way you can match them, by using escaping characters. And here you have an example. Okay, now for character escapes, I showed you how to match this thing. I wanted to complete the example by matching a whole form, which is name, last name, phone number. I wanted to match correct phone number like 35989 888 20 20 4 7 8 9 10. Yeah, so this is a phone number in Bulgaria, by the way. And then I want you to write a regex to match it. And then I want to have gender, and it can be M or F, and that's it. For now it's enough. So I want you to complete this example and match this whole part. Be careful about how you match a phone number, and be careful about how you match a gender. By the way, for matching a gender, you would need to use, I think, something we haven't learned. No, actually it's okay. You can use character classes for that. Anyways, this is a bit more complicated and involved example, but it only requires what you already know for you to complete. So try a bit with it, experiment as we say here, and do your best. I'll see you in the next video. Another component of regular expressions are anchors. There are 2 anchors to be exact, and they define a start of the line and an end of the line. How can they be used? Well, imagine that we have this, like before. Let's remove this example here. But imagine that someone has padded it with white spaces. And you want to match this pattern only if it starts at the beginning of the line. You don't want to match it anywhere. You want to match it only when it's in the beginning. The way you can do it is by using an anchor, and the anchor is an upper arrow. When you write this upper arrow, it means I want this thing here, this first character, this first part, whatever it is, to be at the beginning of a line. If it's not, I won't match it. And now this pattern will only match if it's at the beginning of the line. There's another anchor for matching the end of the line. Imagine that someone here wrote last name Mihaylov and partners, which is incorrect, and yet you're still matching this pattern. So you want to say I want this part here to be the end of the line, and I don't want to have anything afterwards. The way you can do it, again with an anchor, but this time you use a dollar sign. So what the dollar sign means is I want this thing here to be the end of a line, and that's it. I don't want to have anything afterwards. So Mihaylov and partners won't work, but if this is in the end, wait, this didn't match. Interesting. Let me try something else. So I want to match. I'll just save it here. Oh, there was some flag which I should have covered. Yeah, it's this. So in order for this to work, you have to go to flags and tag multiline. Basically, the thing is that if you don't have this flag, it means that this whole text here is a single string. And you're trying to say I want to match the end of the string, but you will only match the end of the string if you're way down here. If you want to treat every line of this input as a separate string, you should have that multi-line flag on. So now when you have that, notice how this thing here, Mihaylov, matches when it's at the end of the line. If it's end partners, it doesn't match. Now let us get back to the previous example. I hope it will work this time, and yeah, it does. So now Mihaylov works because it's the end of the string, but if I write end partners, wait, I should have put the dollar sign here, it doesn't work, and when I remove them, it works this time. Okay, so that's about the beginning of a string and end of a string anchors. You use an upper arrow or a dollar sign. Here's an example. This is a bit more involved. We haven't seen this yet. What this syntax means is previously we saw quantifiers, which could say I want to match something at, let's say, 1 or more times, 0 or more times, etc., etc. But what if you want to match something exactly 10 times? The way you can do it is by using these brackets. Let me show it to you. So I have a phone number, plus 359 89 444 2020. So now I write I want to have a plus, I escape it, I want to have some digit, I want to have it many times. So now when I have this, it matches this pattern. But what if I had a bigger number, like this? It will also match. What if I have a shorter number? It will also match. I want to match a number only if it has 10 characters, no more and no less. In that case, what you can do is you can use curly brackets and specify a number. This number here defines how many times you want this to match. In this case, it matches 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Now it has to be 12 actually in order to be valid. However, notice that although this works, it still matches part of the incorrect pattern. What must you do now to match it? Expect the end of the string here. In order for a phone number to be correct, it should have 12 digits and it should be the end of the string. There shouldn't be anything afterwards. Okay. That's for the curly brackets. And one more thing you can specify is a range. You can say I want to match anything between 4 characters and 12. In this case, it says I want to match this because it has more than 4 characters and it has less than 12, and it matches this because it's exactly 12 characters. So that's another way of specifying exactly how many times you want something to occur. For example, this you can use in order to check how big a password is if you are making some kind of login screen or whatnot. Okay, cool. So that's about anchors. Now let's give you a challenge with anchors. What challenge must I give you? Well, anchors are quite simple actually, and I showed you all the use cases that I could think of, to be honest. Well, let's say you have a let's keep it simple. Have a phone number, and I want you to complete this example so that when you have white spaces in the beginning, the phone number is not matched. It's a very simple one. So think about it. It just uses an anchor we already covered. I'll see you in the next video. Now it's time to practice a bit more formally. We have to match a full name. We should already know how to do this. You're given a sequence of words, you should find those who are full names. You can use Regex API. Okay, cool. So I have full names here. No, this isn't full name. So, Ivan, Ivanov, George, Michael Jackson, Terry, John. Okay, cool. So that's the words. Now we have to match them. So what is a full name? So it consists of a first name and a last name, a space, a first name and a last name. Now we already know how to match letters, don't we? We can use character classes. So we can write from match everything from A to Z plus, space, anything from A to Z plus. However, we have an uppercase character as well. That's why before we match this, there should be an uppercase character here. So we should start our words here with the possibility for one uppercase character, and it should be a necessity. And now notice what we get. We get Ivan, Ivanov, George Michael, Michael Jackson, Terry John. Okay, cool. And yep, that's our full name essentially. We get an uppercase character in the start with an uppercase character, get one or more lowercase characters, an uppercase character, and one or more lowercase characters. Let us see the actual solution here. It's very similar, as you can see, but there's one more addition. It's this B thing. What's a B? Well, it can come in handy sometimes, but essentially it matches a non-word separator. So it says, I want this thing here to have before it some separator. In this case, it's not necessary, to be honest. I can't think of a case in which it will be. Maybe, no, I can't think. Sorry, but essentially, if you want to match the start of a word, you can use the B character. Experiment with it. Maybe you can find some use case where it can be useful. But if you don't use it as well, you do well for most tasks. So that's our simple problem here. We actually did way more complex ones before. So this is just a recap. We have character classes, we have quantifiers, and some special escaping characters. Now, if you haven't already, try it yourself. This is your challenge, and I'll wait for you in the next video. Another concept of regex is called groups, which can become very handy sometimes. So imagine that you want to catch the following pattern. Peter is Peter, and that's it. And you want to catch a pattern in which this part is constant, and this is a word, so this is any arbitrary word, as long as this part here is the same as this one. So you want to match any word you want, but you want the second part to be the same word. For example, you want to catch Peter is Peter and that's it, but you don't want to match Peter is George and that's it. Okay? So how do you do that? Well, first you can write the constant part is a word and that's it, and a word. So now notice that we captured both patterns because we're saying as long as there's any word in these two slots, we'll match. But now, how can we say I want to match this only if the second word is the same as the first one? In problems like this, you can utilize groups. What a group is a actually zoom in. What a group does is it essentially doesn't add much to the capturing itself, but what you can do is you can have groups and later use them and repeat them. For example, you can say the way you create group is you can write this. After you do this Peter here is now a group. You grouped him. So far nothing happened, but since Peter is in a group now, you can say I want to match the result of the first group. And now it says, look, the first group consists of a word, any word, but the second word can only be valid if it's whatever the result of the group of that first group is. And you can have more than one group. In this case, this worked well. Peter is Peter and that's it, and the other pattern didn't work. So this says match the results of captured group 1. That's what a group does essentially. You can use it many times. You can, for example, add it here as well, and you might expect here to have Peter as well. Otherwise it won't be valid, as you can see. You can have more than one group. You can, for example, add this in a group as well and expect it to come here. For example, Peter is Peter and that's it, and well, that's it. Okay, so here we have group 1, which matched here and here. This is group 2 and it matched here, and that's what we define with this pattern. So essentially that's how a group can be helpful. It allows you to group an expression and reuse the results of it afterwards in some problems like this. So you have some sub-expression, you put it in normal brackets, and then you have a group. You have a non-capturing group like this, which means that you can't use it, and it's defined like this. To be honest, I've never used this part because I don't see any reason for it. But essentially when you have it, what it means is you cannot use it. So this is a non-capturing groups, and you can't say I want the result of group 1 here because you haven't captured group 1. This is just, you're just taking advantage of the brackets without defining a group, which to me really is pointless because you can just use the normal groups, and the other thing just adds clutter. Okay, so that's groups. Now you can practice with it, and the way you can practice it, I want you to match a 5-character palindrome. So a palindrome is something which reads the same way from left and right. ABC, BA is a palindrome. PAD, AP is a palindrome. PAD, PA is not, because it doesn't read the same from right and left. You want to capture a 5-letter palindrome, and that's your task now. Do it with Regex, and one hint here, use groups because they will be very helpful. So that's what your challenge for learning how to use groups. I'll see you in the next video. So back reference constructs are something we actually already covered. Essentially it helps you get the result of a group, and we saw how to do it. The first type of back reference is slash some number like this, and it tells you expect here the result of the capturing group you define with the index you specify. For example, this is a back reference like that. You say here, I want the result of this group. This group matches Peter, and I want Peter to be here as well. So you already know how to use it. The second thing, however, we haven't seen. It's another variant, and this way you can still match the result of a group. However, you can match a name group. That is, you can specify a group not by its index, but by a name which you'd give. For example, here I can write question mark name, and this means what this group which I just captured is called name. So you can refer to this group with the alias name. And now instead of writing 1 here, I can write k of name. However, one bad part here is that this doesn't work in regexr.com. The site just doesn't work with those kinds of regex. But if you go to regex 101, this works. So this is another, well, it's the same thing as regexr, but has different interface. And it seems that it supports these name groups. So let's see how it works. Notice how this pattern matched, which was the same as before. This is group 1, and this is the result of group 1. However, this time we didn't refer to the group by index, but we refer to the group by name. So you can use this construct here, naming groups explicitly, in order to bring a bit more clarity. For example, if you mess with too many groups, having groups 1, 2, 3, 4, 5 can be hard to trace. That's why you can use named groups. And I'll give you an example of a task in which you need to do it. So let's say you have the following line: 20/01/2018. Today is 20/01/2018. You have these two lines, and you want to match the first one and not the second one. So what you should do is you should check whether this is the same as this, or maybe to make it a bit more hard, the day is 20, the month is 1, the year is 2018. So you want to match all the three parameters. The day is 21st, the month is 01, the year is 1995. So we want to match line 1 and not line 2. So this can be achieved with naming groups a bit more easier. First, let's match a date. So we have a digit, a dash. Let's see what this is. Yeah, it's the character. Digit, dash, digit. Then you have a colon. The day is, well, this is what we'll fill. For now, just write this. The month is this. The year is this. So that's all your regex. Now we want here to match the result of the first group. That's why we can add groups. And we can add it like this. So now we have 3 groups, and we can refer to them with back references. I can write 1 here, 2 here, and 3 here. And as you can see, the first line matches, the second one doesn't. In this example, it was a bit straightforward to use these groups, but imagine it was a bit more involved. Maybe you don't want to use numbers because you have too many groups, you want to use names. When you want to use names, you can add name groups. So I write question mark day, question mark month, question mark year. So I want here to have the day. This one should be the month with a K. and this should be the year. So now I achieved the same thing, but this time I use name groups. This way your regex is a bit less cluttered and more easily read. Maybe not. So name groups I would use in rare circumstances because you don't want to make you don't want to make your regexes too complicated. But when it gets complicated, this can help you achieve more clarity. So that's about back reference. Essentially, it's something which helps you catch the result of a group. A challenge for you is to understand what this regex and this one match. I haven't explained them. You actually have the result here, but I want you to read them and understand why this matches the regex, okay? And this one also. So it's a bit of a decryption task for you. Okay, cool. That's about back references. I'll see you in the next video. So now we know how to work with regexes. We know what they are and we know how to use them in some sites. Let's now see how to use them in our computer programs. That's why, for that purpose, we will explore Regular Expressions API Part 1. So first we start with declaring a class which allows us to use regex in C#, and the class is called regex. It's part of the system.text.regularExpressions namespace. Regex pattern is equal to new regex. Here I specify the pattern. So first I have to include this. I click Alt Enter. It suggests this, which is correct. I accept. You have the namespace included, and now you can start using it. So the pattern I will use is this one. Here I specified, and let's say I have some text which I want to check if it matches the pattern. So here's my text. I add it here. And first of all, I have to notice how I have these errors here. The errors occur because C# thinks this, I'm trying to escape the K here with an escaping character. And it says there's no special character K whatsoever. So he's throwing an error. For regex, you would have to double escape, well, you have to escape backslashes in order for it to work. So you have to add additional backslash here, like this, everywhere the backslash occurs. And I think that's enough. Okay, now what you can do is you can use the isMatch method. The way you can use it is you just write if pattern.isMatch of some text, then say the text matches, else say the text it doesn't match. After I run this program, I see that the text matches. If I change this to George, it no longer matches. So that's how you can use the knowledge you just learned into your computer programs. One suggestion I'll give you is when you're writing regex, when you're using regex in some tasks, I would advise you to always start from this site, regex101.com or regexr.com. The reason is that here you have immediate feedback and you can see if anything's not okay. For example, if I accidentally put a white space here, I would immediately see that I won't match my text. But if you do that in C# and you immediately put a white space here, the text doesn't match, although it looks okay. So I now have to debug, which is not okay. That's why a suggestion is always start from these tasks, always start from this site, and then go to the source code. So that's about the isMatch method. It basically checks if a text directly matches your pattern. Another thing you can use is the match method. The match method basically returns something like a substring which got matched. For example, if I want to I want to extract a full name out of a text. So first let me remove the patterns. So I have hello, my name is Nov, And that's it. So we wanna extract this full name. Let's first copy our text and put it here. So I want to match a full name. Well, a full name starts with an uppercase character. It has lowercase characters, and I use the plus quantifier in order to match them, and then this repeats. So that's how I extract the full name out of this string. Now I copied this pattern, I put it inside my regex, and I can say match m is equal to pattern.match of the text. And now I can use this. This is actually something which gives me access to the substring which got found. For example, I can say write m of 0. Well, m.groups of 0. A bit strange, but anyways, this will return the substring which got matched, person, person of. So that way, if you have a large text, you can extract, let's say, all the full names. Well, for now we just know how to extract a full name, but soon you will learn how to extract many names or whatever you need and work with them. So regex is very useful for data manipulations like that. So that's the match method. Now try these two methods out, isMatch and match, and I'll see you in the next videos. Now let's explore some additional methods of this Regex API. The first one is looking for matches. That is, what if you don't want to extract just a full name out of a string, you want to extract all the full names. For example, here I have hello, my name is person, personal, this is my friend Billie Jean, and my other friend Laura Evans. So you want to extract these names. Now if I just have this text here like this, I paste it, and I just find a match, I'll find the first full name. But what if I want to iterate through all the full names and extract them all? In this case, you can use not match but matches. What this returns is a match collection which can be iterated. You can say for each match m in matches. This should be renamed now. I want to write match.groups of 0. So now I can have all the full names by for eaching the match collection. Apart from that, you have some additional space info, like let's say total names found is matches.count. So you can see how many full names you found in total and things like that. Okay. One thing here is that when you have groups, you can access them by using this indexer. Something I didn't show you. Let's say you have this example. Okay, you want to match this. You want to match a digit, a digit, a digit, but you want to add groups. So the day is /1, the month is /2. We already saw this, just repeating it. Okay, this is my pattern. It has some groups in it. I put my pattern. Well, I have to escape now. Every backslash there is here. Okay, cool. So that's it. That's my pattern. Now I just need the text. This is my text. And now I want to find a match. Match m is equal to pattern.match of text. So now if I write m.groups of 0, I'll get everything I matched, the whole string including. But if I ask for the specific groups like group 1, 2, and 3, what I'll get is the captured groups. For example, groups of 1 gives me 20, and this was the first group. Groups of 2 gives me 1. Groups of 3 gives me 2018, etc., etc. So this way I can extract some specific groups out of text. For example, what if you have a text with a date in it and you want to extract the day from that date? Well, first you gotta match a text with a date, which you can do with your knowledge so far. But if you also add a group to your day, let's say, you can easily extract it later. So that's for the match API, and that's matches. Basically, it helps you give you a match collection in which you can iterate. You can also replace. You can say, hey, I have some text and I want to replace something. For example, let's say you want to hide all the names in a text. So I want to match a full name with my notorious regex, which is plain and simple like this. Now I want to censor this string. I can say, look, here's my regex. Nothing needs to be removed. Here is my text. Okay, and now I can say, well, pattern dot replace text. Wait. Yeah, so I should add the text and the replacement, which is 5 stars. Or maybe like this, since it's a full name. So this returns a new string. Okay, cool. As you know, strings are immutable, you can't modify them in place, that's why I need a result like this. And now I can write the result. So notice how I just had a text and I have just hidden all the names in it. An easy way to achieve it is using regex, as you can see, and the replace functionality. And finally, the final thing we'll see of this class is splitting. As you know, when you have some text, normally you can split it by specifying some characters. But sometimes it can be way easier to just use a regex. Let's say you have a text which has numbers 1, 2, 3, 4, 5. You have these numbers and they have unspecified white space, length of white space between them. One way you can split it is by using the method we already know. Another way is to use regex, and you can say, look, I want to match all the white space characters there. I want to match a white space once or more. So you match this regex will match this part, and all the others. And now I can say pattern.split text. This will return a string array of tokens, and now I can iterate through them. For each string token in tokens, write the token. And once I do that, well, first I have to escape. Once I do that, I get all the numbers. That way I can get a string and split it no matter how many white spaces it may have. This can also be achieved with the normal split utility you already know from the previous lecture, but you can also do it with regex. And there might be some other more convoluted example in which you have multiple characters. For example, let's say you can split by white space, you have some special characters and things like that, and you still want to extract the numbers. So how do you do it? Well, let's just use that here. First you need a character class. Specify all the special symbols like this. Yep. And match a white space as well. Then you match any of those multiple times like this, and you split by them. And once you do that, you still get all the numbers. So that's an example of an input which is a bit harder to parse using normal utilities, but with regex it's relatively easy. Okay, cool. So that's about splitting, and that's about the regular expressions API. We learned isMatch, match, matches, split, and replace. So let's recap. isMatch returns a boolean telling whether the text matches the pattern or not. Match returns exactly one match, which is the first case in which your pattern hit something which matched it. Matches returns a collection of matches which can be iterated. That way you can, for example, extract all the full names out of strings, not only the first one as in the match case. Then we saw replace, which allows you to replace a pattern you encounter in a string with whatever text you specify. And then you can have split. This is the final thing we covered, which allows you to split a string using regex, not using an enumeration of characters. So that's about the regular expressions API. Play a bit with it, and you have the opportunity for that in the exercises. I'll see you in the next video. Now we have to learn what we learned in this lecture by it's called replace the API. So you're given an text, and we have to replace the data with a variable. Don't know what the HTML text is. It's not important at this point. What's important is to understand the format. Essentially, we have a text in which we content that imagine you don't verify what you have anything to learn. When your content stop counter controls that in other words, which is not a closing back bracket. And we should continue acting until we encounter one. In other words, we can use this, the closing tag, but we match anything which is different we match it multiple times. This way, we match the content between the tags. Look, there are between the tag cannot be a closing bracket. Anything else, but not that. So I match everything out of the closing bracket and I match it multiple times. And the closing bracket. One thing is that I will have to use the star instead of the asterisk instead of the plus, because if you have this tag, it's okay. So for example here, previously we had this that if this was an empty tag, we would match it. However, we do have to use it. That's why we use an asterisk which says match this element 0 or 1, or which means that you can either have content or have none. Okay, cool. That's the open. Now we know how to cover both. Let's try it out. We have Regex open tag. New Regex this. Closing tag button is equal to new Regex closing. So now how to use it? Well, our text. So we have text input terminal, and we have read element counter the end. So and read it again. Now in this way, I write any text I want, and once I finally write it, I've done it, which is all we do is do it with text here. So we know that we have to replace all the tags, but we know how to place things in Regex. We can write string result is equal to text dot opening tag button dot read. use it in our pattern, but we use it in our that is we want to take capture group, we want to put this in a group, this whole thing here, and we want to include it in the and that's what we done in our well, actually here in the string, we just say, well, what we might say is -1, because you expect that it will work the same way as in the Regex normal way. But unfortunately, it doesn't work this way. This will just write plain 1 and 1 here, I mean the results of capture group 1, which is this content of what I'm going to include it in the capture group. This won't work still.